Review with Unit 1, Number Theory. Please witness this fabulous joke of the day before you. Hope you have taken ample time to appreciate that. Okay, let's talk about the stuff we did in Unit 1. Some of this is going to be like, Miss Lambert, why are you taking the time to review this? Because I just need to make sure we're on the same page. And other stuff you're going to be like, oh yeah, I buried this in the depths of my mind of Unit 1 for a reason. So the first thing we got to talk about is combining like terms. Wow. Think of how far we've come. Just a reminder, like terms are terms that have the same variable and the same exponent. And all we're doing to combine like terms is adding together their coefficients. So I could have a lovely polynomial over here, 5x cubed minus 6x squared plus 2x minus 7. And now I'm gonna take that and add it. You know what, I'm actually gonna go over subtracting. Woo, look at me getting all fancy. And let's say, I'm also gonna put this out of order because I feel like it. Maybe let's go 8 minus 6x squared plus 10x cubed minus, changing my mind, minus 7x. Okay, combining like terms, everything with the same variable, same exponent. First thing, please make sure this subtraction is applying to all of the things, so we gotta distribute through. So really, keeping all that the same, that becomes minus 8 plus 6x squared minus 10x cubed plus 7x. And now I'm looking at all of my like terms. And we're going to write this in standard form, aka highest exponent to lowest exponent. 5 minus 10, I get a negative 5x cubed. Up next, I'm going to go squared, negative 6 plus 6, that's 0x squared. Cool. So now I got 2x plus 7x plus 9x, and then my minus 7 minus 8 minus 15. There we are, combining like terms in standard form. Thank you, Unit 1. Okay, I do want to talk about how to classify this. Remember, we can classify based on terms and also our leading, our highest exponent here. So as far as, actually, degree, that's the word I was looking for, degree. Okay, so if your degree is 0, then turns out anything to the 0 power is 1. Oh yeah, don't worry, we'll go over that next. So if your degree is 0, you have a constant. If your degree is 1, meaning you have x to the first, then it's going to be linear. X squared, quadratic. X cubed is cubic. Anything 4 and above, we're just going to call it the 4th degree, the 5th degree, so on and so forth. Okay, so we also classify by how many terms you have. So if you have 1 term, it's a monomial. 2 terms is a binomial. 3 terms, trinomial. And if it's 4 or more, then we'll call it a polynomial. So I can take a look at this lovely polynomial that we have up here, and we're going to get more specific, and I know that this is going to be a cubic trinomial. Thank you, Unit 1. Let's move on. Okay, next we're going to talk about multiplying polynomials. our good old friend distribution over here, we're just going to take the x squared and multiply it by all those things. X squared times x is x cubed. X squared times -6 is -6x squared. I like to line up my like terms as I go because it's easier for me. -6x times x. Oh yeah, because does that negative go with it? Yes. Yes, it does. -6x squared. That becomes positive 36x. And now I got this 4 to get positive 4x minus 6. And now when I combine my like terms, x cubed minus 12x squared plus 40x minus 6. Okay, now we're going to get into the fun stuff that I know all of you missed, all of our exponent rules and stuff. Okay, first thing that we need to know. A fraction exponent represents a root. So if we remember, x to the 1/2 power really means the square root of x. Y to the 3/4, the denominator is the index of the root. Ooh, there's some vocab you haven't seen in a while. Index means the kind of root you have. So the denominator of the fraction is the index, so I know this would be a 4th root. And the numerator is the exponent of the y. You could also see this written as the 4th root. Wow, except I wrote 3. Okay, the 4th root of y all being cubed. You see it written either way, and either of those is going to be the same thing. So as far as the actual rules go, this is lesson, wow, we did this in 1.1, friends. This is literally the first day of class that I had you. What beautiful memories. Okay, anyway, here's our rules. I'm going to do them in notation wise. If I got x to the m times x to the n power. Basically, same base, they're being multiplied together. All we're going to do is add their exponents. So I could have x cubed times x to the 4th. Well, I know altogether, if I got 3 x's being multiplied over here and 4 over there, well, that means altogether I have 7 of them. So that's why we just add their exponents. Okay, if I have anything to the 0 power is always going to be 1. If I'm dividing two things, then we're going to subtract their exponents because that's like things canceling. So if I had y to the 5th divided by y squared, then this would get me y to the 3rd because 2 of them would cancel out from the bottom. And then we also had, oh, anything to the 1st power is itself. I don't feel the need to write that down. Oh, I remember, negative exponents. Let's call it negative m. Negative exponents are all about reciprocals. And so it's really flipping the spot in the fraction. So that means if I had 1 over x to the negative m, then I would switch it to its reciprocal because that would be over 1. So negative exponents just represent reciprocals. So if I have 5a to the negative 3, Riddle me this. What is your exponent attached to? Just the a, which means the 5 would stay on top and the a cubed would go down. And once you switch its spot, the negative exponent goes away. And so we took 2 days, one to explore this rule and then one to do it with fractions. And so let's say, for example, I'm just going to jump in with fractions. I have no idea if this is going to be pretty or not because I am winging this. X 2/3, Y 7/2 over, oh, I forgot a rule. So I'm going to do this. X 1/2, Y 1/3, all of that raised to the 4th power. This is the rule I forgot. If you have an exponent raised to another power, you get to multiply those exponents together. So I get a hot mess like this. Our job is to take it and make it a lukewarm mess. I usually start, like, I go numerator by denominator and say, is this fully simplified? Numerator, is that simplified? Yeah, I can't do anything else. So then I'm going to take each of those and raise them to the 4th power. So the numerator stays the same. The bottom, remember that's like a 4/1. So x to the 4/2, y to the 4/3. Well, hey, I know 4/2 is the same as 2, so that's actually going to become x squared. And now we can just subtract from what's going on here. So I'm going to start with x's. 2/3 minus 2. I'm going to common denominator that thing. So I get negative 4/3 for x. Y 7/2 minus 4/3. Common denominator this. And 21 minus 8 is 13. So what I got is whatever you subtracted is going to end up on top in the numerator of your fraction. But we don't like negatives. So that x is actually going to come down for the positive 4/3. Whew, what a trip.